So, starting off with DP1.1, they ask you to remember what is the order of a matrix. That's the first thing you need to know. What is the order of a matrix? What do they mean by that? It's dimensions. Okay, so I'm going to write here. This means dimensions. What's an example? When they say a dimension, they could say you have a 3x4 matrix. This is what dimensions refer to. But going back to your notes, and it's already down here, it talks about the order of a matrix. I've already copied the notes down for you to refer to. 3, what does 3 represent and what does 4 represent in this case? Go back to your notes. What does the order? 3x4 matrix, what does that look like? Yes?
3 rows, 4 columns.
Very good. 3 rows, 4 columns. So what you should expect, using square brackets, you should have 3 rows. So say A, B, C, and then 4 columns. So that's the first column. D, E, F, G, H, I, J, K, and L.
I'm sorry, you're in the flow. Just there, I interrupt.
I'm so in the flow right now, aren't we, guys? You're actually getting recorded while I'm doing this too. So we've got Mr. Ponte here. What would you like to say?
Could I please grab Ronnie for a sec?
Oh yes, I didn't want to record that actually. Whoops, my bad. All right, so we've got 3x4 matrix. That means it's a 3 rows by 4 columns. So right here, I'm just going to put 3 rows by 4 columns. So that's the order of a matrix. Very good. Next part is they talk about types of matrices. You have a row matrix, column matrix, square matrix, diagonal matrix, symmetric matrix, triangular, zero, binary, and identity. Normally, you don't need to know that many. You probably work with matrices and you kind of know what they are, but sometimes they'll use these key terms. How do you know them? I already combined them all into this section here. So see how I wrote types of matrices? If you've forgotten what they are here for you to see. So row matrix obviously is just the row. Column matrix, just the column. Square matrix is obviously a square. It's an even 3x3, 4x4, or 2x2. Diagonal matrix, that one you might want to read up. Okay, and symmetric and triangular and zero matrices are all under types of matrices. Okay, so I've got it all under one table there for you. All right, so that will tick off that section. What else do you need to know? This part you might have learnt already from your previous years. But what does transpose of a matrix mean? Because there's another section, there's a question that gets you to practice transposing a matrix. What does transpose mean? Yeah, and that's essentially it. That's essentially, if you've got, as an example here, you can see this is a 3x2. This is 3 rows by 2 columns. That's the order of this matrix. When I transpose it, I'm essentially swapping, and it becomes a 2x3. Okay, so 2 rows by 3 columns there. But I do want you to pay attention that the numbers do matter. See, notice this is the first column. So the first column becomes the first row. Second column becomes the second row. So it does matter which ones you're going. And this is the first row, first column. So it becomes the first row, first column. Does that make sense? Okay, so each one gets transposed, but the order does matter. Okay, so most students understand this concept. But when they start writing it, if you don't practice it, you may get confused when they do a sort of bigger matrix to transpose. Okay, all the numbers switch. So if the position here, we would normally say that's a position 2, 1. So row 2, column 1. Then when you transpose it, you should expect it now at row 1, column 2. That's what you should expect. Okay, so when you swap it, you notice it's now row 1, column 2. Okay, so just if you understand the idea, you're swapping wherever the X was now becomes Y, and wherever the Y is now becomes X. That's essentially what you're doing. So it's not only just the dimension, but it's also the positioning of each element. Okay, so that's transposing. And did you know you can do this on your CAS? Hands up if you know how to do it on a CAS.
Yep.
Yes? Okay, for those who don't, I'm just going to quickly show you as well. On your CAS, I'm just going to go here. I'm going to add in a matrix just to visualize. Here we go. Let's add on a matrix. Oh, so that's a bad matrix. Let's do one that you can transpose. Let's do menu, and I'm just going to go pick this one. Let's do a 3 by 5. So there's my, oh no. Man, that's a lot of numbers for me to put in now. Okay, here we go. If you want to transpose this, there's 2 ways to do this. If you didn't know, you can do control and that book that you have there. If you do control book, there's a letter T right here next to the plus minus sign. That letter T means transpose. If you put that T next to it, it will transpose it for you. Or you can do what Matt was saying before. You can simply go to, and this is how I do it as well. I just simply go to menu matrix, which is 7, and then transposes 2. So menu 7 2 does the same thing. Okay, so you've got 2 ways to transpose there. So that's one thing to keep in mind. So that ticks off how to transpose a matrix. And then finally, and what I'm covering here is actually from 11A to 11D, excluding 11B. Okay, so this is all the skills that you're revising. So here we go. You need to know how to sum and difference matrices. You need to know how to do multiplication of a scalar, and then this is where it's slightly different, product and power. Okay, that's why if you looked at my pages here, I've separated it. Okay, so otherwise it's just too condensed there. So D and E is to do with product and power, and then the first part is to do with add, subtract, and then all the other reviews of your dimensions. Okay, so that's what DP 1.1 is. All of that, those 4 exercises will cover the first dot point that you need to know. Okay, so here we go. Let's review. What's the rule for adding and subtracting matrices? What do you have to make sure? What do you have to make sure? In order for you to add 2 matrices, what must occur? What must occur? Very good. Same matrix. Okay, so the order has to be the same. So sums and difference, orders must be the same. Sorry, there's something's wrong with my pen. It doesn't doing these squiggles. Yeah, it's all right. Must be the same. So what's an example? Let's have a look at some examples here that they might give you. Hey, welcome.
Sorry, I'm late.
That's all right. You're here. If we're going to look at some examples, is in 11C. This is a good example here. Can you see the 2 matrices have to have the same order or dimension in order for you to add or subtract? Okay, so that's the first thing. So to add or subtract, you need to make sure the matrices are the same. And again, you can do this on a calculator, but they also need you to know how to do it by hand. Okay, so do it by hand, check with a CAS. All right? Now, lastly, just a last revision. Ooh, yeah, the pen's still not working too well. That's okay. Last one, team. Listening. Shh. Product and power. I think product is probably the next one. I think most of you know how to do it on a CAS, but you do need to also know how to do it by hand. Okay, so let's do a bit of a revision on how to do this by hand. When you're multiplying matrices, there's a rule. Does anyone remember the rule for it? So say in this particular case here, you've got a 2 by 2 matrix, and you're multiplying by a 2 by 1 matrix. What do you have to make sure about these 2 matrices in order for you to multiply? Because you have to check if you can multiply it or not. What's the rule again?
The first one, the amount of columns on the first one is to be equal to the amount of rows.
Very good. So the column of the first matrix has to match the row of the second matrix. If they do not match, you cannot multiply them. And the last tip, if you do, if you multiply it, it should be? Very good. So the outside, so the row of the first by the column of the second is the resulting matrix you're going to get. Okay, so that's the first step. Second one is you need to know how to then do it by hand. All right, so let's take this example A. You've currently got 6, negative 4, 0, 2. That's a 2 by 2, multiplied 2, 3, 1. I'm not really impressed with the pen at the moment. I'm going to see if I can... a different one. Let's see if this one works. Alright, that's better. Alright, how do we multiply them? We know that the result has to be a 2 by 1 matrix. How do we multiply a two rows by 1 column matrix? How do you get the result? How do we do this again? What's the technique? So I just need to know that you're okay with this, then I'll give you that time to practice with your CAS, but I want to know that you can do it by hand. How do you multiply again? Anyone know? How do we multiply 2 matrices again?
Did you go first row? So you get it times.
You do first row?
6 times 0 plus
6 times 3 plus 2. And then 4 times 1 plus 2.
Very good. I was wondering if someone was going to pick up on this mistake here. So, why can't you multiply them?
Because the first one has 2 columns, so the second one only has 1 row.
So what should the dimension of the second one be?
1 by 2.
Very good. This is a 1 by 2, so that's the first step. If you're already seeing that you can't figure it out, it's probably indicating that there was a mistake somewhere, or there's an order that's different. So right there, I wrote 2 by 1, but it's not. It's 1 row by 2 columns. So